Alright, Bismillahirrahmanirrahim. Assalamualaikum. So today we're going to start with data visualization using base package. So the data set that we're going to use, empty car data set, pressure data set, air quality data set. So these three data set are ready-made data set from our package, base R package. And we're going to use another three imported data set. So these three imported data set are available on my data set from my website. So you need to make sure you download the data set from my website. You need to set the working directory. So working directory, please choose data visualization number 6. Right, so go to data and set as working directory. So in our directory, you should able to see all the data set that we are required lah. First is TB incidents.xlsx. Another one is YTS dataset, which is Yard Tobacco Survey YTS dataset.csv. And the last one is probably dataset probably.csv. Right, so let's look at the data set, each data set manually. So let's look at the empty cars data set first. Empty cars. So in empty cars, basically we have 11 variables and 32 observation. Right, each variable consists of the name of the car. Right. So for data set pressure, so in pressure we have only two variables and 19 observation. So the first variable should be temperature and the second variable is pressure. For air quality, data set, basically we have 153 observation with 6 variables. So the variable are ozone, solar.r, wine, temperature, month and day. Right, so let call the data set for TB incidents. Since TB incidents is Excel file, right, XLSX. So we're going to use a library read Excel. So TB. So we're going to call a library read Excel to import Excel dataset. So to use read Excel to import Excel dataset, we're going to use function read_Excel. So let's name this object as TB read_Excel. This is a TB incidence, right? So let's call the name of the dataset TB incidence.xlsx. So we just call this data. So are you okay with that? So this is the first step. So let's look at TB incidents data set. So let's look at head of TB. So in TB we have basically 19 variables with we have 19 variables, right? And the first variable is TB incidence. So let's look at the full name of that variable. Of TB. So the first name is quite long. The first variable name is very long. So we need to rename this first name to country. So how to rename? To rename the variable name, it should be very easy by using dplyr package, right? We're going to rename first variable to country, right? So TB, we're going to use function rename, but before we use this function, we need to call the library dplyr package, right? So then we can use rename function, rename the function dataset TB. So the new variable name is country equivalence to the old name. We're going to change the old name, which is TB incidents per year. So this is going to be, yeah. Oh, cannot. Why? Why can't I change this one? Yeah. So I forgot to put the last bracket here, so we should be able to change the name lah, or rename the variable name. So you need to copy everything in the first variable name, right? So the name for let's say, let's look at the name of TB for variable number 1. Oops, it's already changed to country, right? So this is the way we change the variable name for the first variable, right? Let's look at in this data set, right? If you look at the names of TB, so we have basically 19 variables. So from country, year 1990s, 1991 until 2007. So let's say I just want to select the variable that have year before year 2000. Means that I want to select variable including country, year less than 2000, before year 2000 lah. Means that it's going to start with 1, right? So now I'm using a dplyr package. Let's say I'm putting avg, the new object, dplyr, right? I'm going to select TB with start with 1. Another one is, so if you look at avg now, right, the name for avg, it will only select year 1990 to year 1999, right? So that is the objective lah of my this is, I'm not going to include in country as well, just year before year 2000 only, right? So next dataset that I'm going to import is YTS dataset. YTS dataset is your tobacco survey. Your tobacco survey YTS dataset.csv. So this is a CSV data file. So I'm going to store this dataset to YTS object read_CSV. So by using read_CSV is sorry, this is .csv. I'm trying to use another function which is read_CSV. So read_CSV is a function from readr package. So you need to call readr package, right, in order to use function read_CSV. So I'm just going to copy the name of the dataset and paste it into read_CSV function, right? So under YTS dataset, basically we have YTS dataset, we have 9,794 observation and 31 variables. The variables are YTS. So we have year, location ABBR, location DESC, topic type, topic des. I'm not sure what is the definition of the variables, right? So now let's say I want to select, I just want to see what inside the dataset like YTS. So basically, we have location, or this is abbreviation, location abbreviation. So we have AZ and so on. This is a location. Topic type, topic means description maybe, right? So what I want to do is I just want to select or filter measure DESC equal to smoking status, and then measure all gender equal to overall, and I'm going to take a response equal to current year. Yeah, this is what I'm going to filter out, because if you look at if you look at inside the data set, let's say view the data set. If you want to view the data set YTS, I think there are a lot of they contain a lot of missing value. Yeah, they contain a lot of missing value. So that's why I'm going to use filter to means that I'm going to select only non-missing value data. So that's why I'm using some criteria to select the data set lah. So to select the data set based on this criteria by using dplyr package. So I already called dplyr package at first, but the function that I'm going to use next is required to use dplyr package lah, because we are using filter function, and we're going to apply some piping methodology lah. So dplyr package. So I'm going to rename this one as sub YTS, right? So from a YTS dataset, so I'm going to filter out measure equal to smoking status. I need to know what is the label from measure DESC. So let's say I'm using table YTS, or you can use class as well, or level YTS. Oh no, maybe class, I'm not sure. Class is to measure the type of variable kan. So the one of the method is to find the level available in that variable is by using table lah. So we can filter or summarize each level. So this is a smoking status. So I'm going to copy and paste here, right? And then I'm going to get gender equal to overall. So let's look at table YTS. Do we have variable gender? So we have gender. So gender here we have female, male, and overall. So gender with the capital G equal to overall. And then for response, I need to select for current year. Response is, let's say, try to get the response variable. So where is the response variable? Yep, response variable with a capital R. So we have frequent, ever, and current. So I'm going to select for a current year. So response equal to current year, right? For this purpose, since we have a lot of variable inside the data set, right? So basically we have 31 variables. So I just want to select some of the variable for a display. So by using select function, so I just want to select year, and I think location, and next one should be data value, right? So now if you want to see the variable, the object that we already filtered out, so we only select 3 variables. Oops, so this is a sub underscore YTS. So we only select 3 variables: year, location, and data value, right? So basically we have 3 variables and 9,000. I don't think 9,000. Sub YTS. So this one we have 419 variables, right? So far, do you have any problem in importing and filtering the variables? Any question regarding importing and filtering variables?
No, sir.
Right. So now we're going to jump into our main objective, which is we're going to learn how to do a data visualization using base package. Using base package. Right. So first thing that we're going to learn is by using we're going to look into some function, which is plot, boxplot, histogram, and density. Right. By using plot, we're going to learn how to do a scatter plot. Right. Scatter plot, and then we got also going to learn how to use a line chart using plot. Right. So now let's look at one by one. Scatter plot. So before we jump into plotting, let's look at the function plot. The plot function, the documentation of plot function. So if you look at the documentation, plot function is from graphic package. So graphic package is a package is already came with together with RBase. So it generate y and x and y plotting. So generate function for plotting of R object. For more detail about graphic parameter argument, so you need to see parameter. So now the general usage of the function is plot. First argument is x and second argument is y. And the x is a coordinate point in a plot. Alternatively, a single plotting structure, function, or any R object with plot method can be provided lah. So to visualize a scatter diagram, you need to remember one thing. Scatter diagram is meant for continuous variable only. Right, so you need to have 2 variable. variable. So each one variable should be in x-axis, another one is going to be in y-axis, right? So this is the requirement. So the scatter plot, usually we are looking, we develop a scatter diagram to look into the correlation or relationship between these two variables, right? So now let's look at plotting. So I'm going to use empty cars dataset. So in empty car dataset, we have so we have 13 variables, right? We're only going to select only continuous variable or numerical variable. Remember, the documentation says that the first argument should be x value. X value means that the variable should be in x-axis lah, and y value means a variable that going to plot on y-axis. So now we're going to look into mile per gallon and displacement, right? So the first x-axis should be mpg, and the y-axis should be displacement. So if you hit enter, R will automatically construct a scatter diagram for you, right? R will automatically construct a scatter diagram for you. So this is a scatter diagram or scatter plot. If you can see now, here we have a negative correlation. When the number of displacement increase, the number of mile per gallon will reduce. Sorry, mile per gallon also decrease lah. So kalau kita tengok kat sini, the number of displacement decrease, then mile per gallon increase. When the number of displacement increase, then mile per gallon at a lower point lah, decrease. So this is a negative correlation. So now, so this function is to plotting scatter diagram, right? So in scatter diagram, by default, you cannot see the title, as this title also does not modified or not labeled yet. So you can label the x-axis and y-axis, including the main title. Wait. Including the main title lah. So now, let's say we want to add a title for the whole graph. So by using plot, the same function, plot, empty cars, that mpg, and displacement. So we just need to add another argument, which is main. Main equal to, main is the title of the graph. Let's say I just type relationship between weight and sorry, this is not weight, this is let's say I change to weight lah. Alright, weight I put it into x-axis, and y-axis I put mpg. So relationship between weight of the car and, let's say if you want to put the second line, you should just put another HTML command, right? Forward n and miles per gallon, right? Nampak? So kalau kita letak kat sini, apa jadi? Alright, dia rapat sikit. Okay. So this is how we create a title for a graph lah, right? So if you want to change the axis title for, let's say, empty car $weight ni I nak tukar kepada weight of the car. So I just need to add another argument, which is xlab. Xlab means x label. We're going to change the label for x as is, which is weight of the car. So nampak tak, I already changed the label for x as is. Now same goes to y as is, right? If you want to change the y as is label, so y label equal to miles per gallon, right? This is how we do lah, we construct a graph, a simple graph using a base package, right? So now let's say you want to change the symbol inside the graph. Means the current symbol is a circle, right? Let's say you want to change it to something else. We're going to use PCH. PCH is if you want to change the symbol, let's say I'm using PCH equal to 4. So now it's already changed to X. If you want to change to 2, you're going to change to triangle. So you can also search for PCH graph, right? So this is the list of symbol and number. If you can see, 0 means for square, 1 is circle. By default, R will plot PCH equal to 1. So if you want to change to 21, it will change to circle with circle again lah. Tapi by looking at this one, kita nampak dia kata circle with fill kan, but not necessary lah. But if you change to 13, so circle with X. Now you can see. If you can zoom a bit, dia nampak lah. Alright. So let's say I change it to 4 lah. I just like to X. And then I think that the thickness of border dalam ni, right, is not really thick. So let's say I want to add more thickness of the symbol, so I just add another argument, LWD equal to what is the size of the thickness. So like, let's say I letak 2, so dia akan jadi more thick, right, compared to previously. Let's say I letak 1, so dia akan balik asal. Let's say I letak 4, become more thicker, right? Let's say 2 is good enough lah, right? Okay, so far can you get it? Very simple. Tak perlu banyak benda yang nak tambah. Let's say another function, let's say you want to plot with color, right? You want to add color inside of the symbol. Let's say you want to change the symbol to red color, right? So I just copy the same function, right? Now I'm going to add another function, another argument. Another argument which is color, COL. Let's say I want to change it to red. So it will change to red, right? And of course, let's say you want to change it to blue. You can change it to blue. Green as well. Right, let's say I just change to green. So it will change to green. And if you think any color that you like, right, of course when we are doing graph plotting, we need to make sure our plot is nice and beautiful, right? So you can also find HTML color codes from our website, right? So HTML color codes, so you can choose any color that you like. Where is it? So any color that you like. Let's say I like this color. Let's say I want to try to find pink color, right? So pink color. So I just copy the color code and I put inside the argument. So it will change to pink, right? So let's say inside your scatter diagram, you want to compare your scatter diagram. Instead of comparing the whole group, let's say we have a cylinder in the data set, right? So table empty cars cylinder CYL. So we have 4 cylinder, 4, 6 and 8. So you want to plot the graph based on cylinder color. So plotting by color by group. So it's the same function, right? So instead of specifying the color directly, we just change this color equal to empty cars to CYL. So it will change it accordingly by group lah. Okay. Any problems so far? Let's say if you are familiar with SPSS, once you every time you develop a scatter diagram, it will show a line cross the scatter point, right? So that line was called as a linear regression line, right? So in R, we can also add line inside the graph to point or to mark our line or benchmark lah. So we just need to add app line. So if you look at the app line documentation, app line. So of course, if you want to add line, you should construct a chart first. So app line consists of some argument. AB is the intercept and slope from a linear of a regression, right? H means the y value, horizontal line. V means the x value, vertical line, right? So now let's say I just want to add a horizontal line inside the graph, horizontal line. So let's say I want to plot horizontal line at y equal to 20. So h equal to 20. And I can put the color, let's say color equal to, let's say red lah, red color. So I already add the line, right? And of course you can add more thick of the line. You can make the line more thicker. Let's say LWD equal to 2, so the line become thicker. So and if you want to add, this is adding line, adding horizontal line lah, horizontal line in plot. If you want to add a vertical line, we just change horizontal H to V. So V, let's say I want to add a vertical line at 3, x equal to 3. So V equal to 3 with the color equal to, let's say, green. And I just need to add some thickness of my line, LWD equal to 2. So now it's already adding some lines on the plot. So this is adding vertical line in plot. Right. So let's say you want to add linear regression line. So if you want to add linear regression line, and of course you need to run a linear regression model first. So let's say just summary LM. This is a linear regression model, right? MPG with empty cast. I think this is a white weight can. So this is empty cast weight, right? Right. So now the regression line is y equal to 37.2851 minus 5.3445. So this is a regression line, and this is x. As we know, this is the A value, this is B value, right? So if you want to add a linear regression line here, right? So just add A B line. A equal to 37.2851 and B is equal to negative 5.3445 with color equal to, let's say another color, blue color, and I just need to add some thickness of my line equal to 2. So now you can see the line of linear regression. So this is how we add line inside the plot, on the plot, and we create a scatter diagram. Right? So do you understand? Any questions so far? This is a very slow lecture, slow and steady. I hope you understand. You can follow the lecture easily, right? So next, I just want to construct a line chart, and of course, each data set should follow the format lah. So if you look at how I construct a scatter diagram, so it based on a long format data set, right? So if I want to create a line chart, so it should also follow a long format. So if you remember, a line chart should consist of x and y axis as well, right? And these two variable for line chart, it should be a continuous variable as well, but it doesn't necessarily both continuous, but x axis can be categorical as well, but categorical with time measurement lah. So now let's look at data set pressure. In data set pressure, so this is a data set pressure. So if you can see, we have 19 observation with 2 variables, right? So to construct a line chart, we also going to use a plot function, right? So x-axis should be, I think x-axis should be temperature, because temperature is increasing in number. Number is in ascending structure. So pressure should be x-axis. Temperature should be x-axis, followed by pressure should be in y-axis. So by using plot function, right, if you hit enter like this one, you will get a scatter diagram. But basically this is a very nice diagram, right? So a nice data. So you will get basically this is a scatter diagram. If you want to add line, you just add another argument, which is type equal to L. L means line. So you change it to line. So now this is a line chart. So if you want to create line chart with point together, right, means that you want to add you want to create a line chart, but when it include the point of the intersection of the two data. So instead of using type equal to L, so you change type equal to B. So it will change it to line and point together. Right. So in line chart, let's say I just make it L, right? So I just biar sini tak apa dulu. Right. So let's say I want to change the line type. To change line type. To change the line type, right? So we're going to use LTY function. LTY argument. So instead of make it by default, so I tambah LTY equal to 5. So nampak sini ada tukar line kepada benda dot line. Sorry, line yang putus-putus. Let's say LTY equal to 6. So dia nampak lain lah. So maybe kita tengok dia punya LTY plot R. So yeah. So when LTY equal to 1, so dia akan dapat a straight line lah. LTY equal to 2, line tu berputus-putus. LTY equal to 3 is very small line yang putus-putus. Dan LTY equal to 4, dia dapat line macam ni, and so on lah. So basically we have 6 line. So you can choose either one, right, that make it your graph beautiful. Let's say you tak nampak dekat sini. Let's say kita tambah LWD equal to 3. So dia nampak sikit, right, the type of line dekat sini. And of course you can add a color equal to, let's say I'm going to change to red. So you're going to change to red. And of course kalau kita nak tambah the title, we just add the main argument. Main argument should be the line chart showing temperature and pressure, right? And X as is. So you never forget the detail of each when you construct the graph. So X label should be temperature, and Y label should be pressure, right? Okay. So when you change it to both, right? Let's see, when we change to both, we can also change the, let's see, both, right? We can also change the type of symbol yang kita pakai. PCH equal to, let's say PCH equal to 4, right? So kita boleh tambah sikit lagi lah. And then we can add another colors yang lain. Instead of using red color, right? Instead of using red color, I just want to use a rainbow color, rainbow 4. So with 4 colors of rainbows. Or let's say I want to use more color, let's say tambah rainbow 12. So dia tambah lah. Alright. Okay. Any questions so far? Right. For our next graph, we're going to look into a bar chart. So bar chart is designed exclusively for a categorical variable, right? But you can mix it with a continuous variable. when you want to add the weightage tu, dia nak tukar kepada continuous variable, okay. But by default, the idea of bar chart is designed for a qualitative variable, basically for a categorical variable lah, right? For qualitative variable, basically this is a for categorical variable, right? So we want to see the frequency distribution. Right. So we're going to use we're not going to use plot function, even though we are allowed to use plot function. If you look at into plot function documentation, right? So if you change type, nampak kat sini type, P is for point. For by default, type is equal to P. That's why when we create a scatter diagram, we don't need to specify type equal to P, because by default type is equal to P. So L is equal to line, B is equal to both, means that P and line, point and line. C is for line chart alone of B. And then kalau kita nampak dekat sini, histogram, we can create a histogram here, but there are no indicator for bar chart, right? So we cannot use plot function. So instead of plot, we're going to use bar plot function. So let's look at the documentation of bar plot. So bar plot is the same, it came from a same package, right? This is description is create bar plot with a vertical and horizontal bar, right? So first argument is height. Height is a vector or matrix value describing bar which make up the plot lah, right? So now let's try to create a bar chart. Bar chart, let's say from our empty car data set, we know that we have 3 level of CYL, right? 4, 6 and 8, right? So I'm going to create a bar chart based on this this data. But if you can see now, let's look at this data. Head of empty cars, right? So the data set is not summarized. The value of CYL, let's say CYL equal to 6 ni, dia tak summarize. Dia tak kira dekat kita we have 7 CYL equal to 6. We also don't know we have CYL equal to 4, the 11, right? So let's say if you are directly use bar plot empty cars CYL, right, you will not get a nice bar chart. So this is not a nice bar chart that we want, because the apa yang bar chart ni buat, dia just tabulate the data, right? So this is not really a best bar chart lah. So that's why you need to understand the nature of your data set, right? So if you want to create a bar chart, means that we want to get 3 column only, 3 bar only, right? With each bar are measured their frequencies. So what we need to do here, we need to create aggregate data. So we need to make aggregate data. So aggregate data means that we're going to use bar plot again, but we're going to table empty cars CYL. Now we will get the nice bar plot lah, right? Okay. So as previous, we can add the title of the bar chart by using main argument. So bar chart showing distribution of number of cylinder. Ya. Saya letak bawah sikit. So let's say I nak tukar X label should be number of cylinder, and Y label equal to frequency, right? And I can change more. I can do more beautifier work dalam graph ni. Let's say I just want to change color equal to pink. So it will change the color equal to pink. Let's say I don't want the border of each bar, so I just start border equal to NA. So it will get rid of the border, right? Okay. So let's say instead of putting all color equal to pink, let's say I just want to change it to some color. Let's say the first color, the first bar should be red color, the second bar should be yellow, the third bar should be blue. So it will change accordingly lah, but wait oh yeah, this is the function that I forgot. Yeah. Okay. So this is a basic histogram construction based on base package in R, right? So let's say we want to create another graph, which is histogram. So remember, histogram is different with bar chart. Histogram only takes a continuous variables, right? From a continuous variable, they will cut the variable into several parts. Several part means that they're going to convert the continuous variable to a categorical variable. So the process of converting that continuous variable to categorical variable is called, but there are a lot of method. One of the famous method is by using stage rule, right? How many category, how many class that you want to provide, and then you need to determine what is your class size and how many class, right? And that is the thing that you need to consider in constructing histogram lah, right? So now we're going to use a stage rule, right? So let's say I'm using to construct a histogram is only meant for one quantitative variable, right? So the objective is to see the shape of the data distribution lah. So whether the data are skewed to the right, skewed to the left, or normally distributed. So in this to construct histogram, so we're going to use histogram function, HIST. So we are not going to use plot function because plot function also can do, but I will show you some disadvantage of using plot function. Let's see, using histogram function, HIST, empty cars, MPG, this is a category continuous variable. So it will automatically construct a histogram. So let's look at the documentation, HIST. So HIST, first argument is your x variable, means the variable, a vector value, breaks, so it will break based on sturge rule, right? And the probability, frequencies, not frequencies. So this is the other argument that we're not interested, right? But if you want to change the, if you have another function, another method to break the variable, you can specify how many breaks yang you nak letak lah. Let's say breaks equal to 10, so dia akan breaks equal to 10 classes, right? So normally we are using standard break using a sturge rule, right? You can also use plot function to create histogram. mpcast mpg, you need to add type equal to h, but it will appear a different histogram, but basically you can get a nice histogram, but you need to add another argument here. But I not prefer to use a plot function because it's too many argument that we need to input, right? Let's say I'm creating a new variable BMI. I'm creating a normal variable, and I am creating n equal to 1000, observation m equal to, mean is equal to 24.2, standard deviation equal to 2.2. So if I call histogram BMI, I will get a nice histogram with showing normal distribution, right? And of course, in histogram, you can add the main, the title of the data, of the graph. We just add a function argument main. So histogram showing distribution of BMI, right? And we can add x label equal to, this is BMI, body mass index, right? And y label equal to this is a frequency only, kan? Frequency, right? And of course you can add the color inside the data, right? Let's say you add color equal to red, contoh, for example. So it will change the color to red lah. And we can ignore the border as well, NA. But if you ignore the border, it will not show a nice histogram lah. Let's say we can change let's say LTY equal to 2. So we can change the type of borderline, right? And others argument yang kita dah guna, LTY, LWD, can also be used in this function as well, right? Okay. And let's say you want to change another color. Let's say you want to use color palette, right? You also can use color palette. Let's say I define the color palette here. Palette equal to color ramp palette, right? So let's say color from light blue to light green, right? So this one should be all here, right? So it will change the color lah. Let's say this one I define 3 only, 1, 2, 3 dia akan ubah balik lah. Let's say I don't want to define anything, so it will not define anything lah. So let's say I define until 10 only, so it will define 10, right? So you can change the any color. So you have a lot of color palette, so you can find color palette, color converter, and then we have palette. I don't think so. You need to find color palette in R in website, right? You need to search how to use color palette. So there are a lot of color palette available out there. You need to some color palette you need to download the library. Some color palette you don't need to download the library, such as a color ramp palette, right? So this is how we construct histogram lah, right? So let's say you want to construct a histogram with a normal curve, right? If you are SPSS user, still stuck with SPSS, you still need a normal distribution curve on the histogram. So you can create histogram by adding curve, and then you need to create this data normal distribution x mean equal to mean BMI. This is BMI again, and then we add another function which is standard deviation equal to standard deviation BMI, right? And we add equal to true, and the color of normal distribution line should be, I think dark blue should be fine, dark blue, and we make it the line thicker equal to 2. Oops, dia tak nak naik. So let's say I tambah break equal to 20, and add another one is frequency equal to false. Yes, you cannot add a frequency value, then baru kita nampak lah, because the probability distribution is based on probability value. So that's why this one should not be a frequency. This is going to be a probability. Right. So this is how we create a normal distribution curve on the histogram. Right. Do you understand? Do you have any question so far? Any questions so far? For the next and the last graph that I want to show to you is a box plot. So box plot is meant for one quantitative variable. So again, the objective is to see the shape of data distribution, right? So let's say we want to create a box plot. So to create a box plot, we're going to use a function box plot, right? Empty cars, just like that. We add the variable, so it will create a box plot for us, right? So let's say you want to create a box plot for one quantitative variable and one qualitative variable. So means that you want to compare your continuous variable with the categorical variable available in your data set. So you just type boxplot function empty cars mpg, and you put your categorical variable next after your continuous variable. So the first argument should be continuous variable tilde, right, followed by categorical variable, right? So you will get a 3 box plot based on categorical variable. And of course, You can add the color. So let's say color pau, right? Let's say this color is not good lah. I tukar sikit. Color I tukar pau 2 equal to C. Let's say red, yellow, and blue. So using to construct a diagram, the main point is you need to get a right diagram. The second point is you need to make the graph beautiful so people will like to see that graph. And the most important part is to make sure the graph or diagram that you develop is readable, right? There are no point of developing a graph that not readable. Is make it easy to readable and senang mata memandang. Maksudnya kita tengok dan boleh baca dan tengok pun rasa seronok. Right? That's why the important part of developing a graph is to make graph readable and easy to look and beautiful. Right? So now it's the same function, same argument yang kita boleh masuk, which is main equal to, so boxplot showing distribution of NTG by CYL, right? And we can also add the X label equal to number of cylinder, let's say Y lab, so mile per gallon. Kejap, I think let's try this one first. Yeah, correct. So we also can change the border. Let's say instead of make it border equal to NA, it will not look bad. So we can change the border to brown, for example. So you change the border to brown, and we can change the line of that border. So LTY equal to let's say 3. So it will change the line, and we can add LWD argument equal to 2. It will make it thicker. So I did think this is quite good, and this is better one, right? And the color is not nice. Let's say pink, right? Yellow, light blue, right? I think that's all for today, right? So your task is okay. I forgot to mention, we can also make it the box plot to horizontal box plot. Just add horizontal equal to true, so it will change to horizontal. For this one, can we use the save function? Horizon. Oops, I don't think so. Horizontal equal to true. No, I think we can see histogram function. Can we change to the representation? There are some way to change the presentation, right, to horizontal histogram, but I don't think this argument will work for histogram, but for bar plot, let's see. Horis equal to 2. Yeah, for bar plot, we just use horis equal to true, so it will change to horizontal lah, right? So this is the best thing in R, right? So instead of for box plot, same as this one, if you can also change the the shape of box, the body of the box by notch argument equal to true, so it will change the type of the body, right? Any problem so far? Any problem so far? Okay. Let's look at the last function. This is going to be very fast. Your task I'm going to give you later. Right. Last graph, which is correlation matrix. Correlation matrix. So basically, correlation, we can see the correlation by using scatter diagram, right? So remember the data that we already convert, which is from a TB dataset, which is AVG, right? So we have basically 10 variables, right? So these variables are continuous in nature. So make sure to create a correlation matrix, right? Basically, we're going to create a multiple scatter diagram, right? So instead of creating one scatter diagram, so we're going to create a multiple scatter diagram and put it into a matrix form. So now we can use pairs function. So AVG. So let's say just selecting let's say 5 as a 5 variable only lah. Kalau banyak sangat nanti banyak sangat kan. So 1 until 5, right? So by using pairs, so I already got a scatter diagram for all variables. So this is a scatter diagram for year 1990 and year 1991, year 1990, year 1992, and so on lah. So we have a positive correlation, all are positive correlation. And we also can add all the argument lah inside the data. Let's say for example, I just want to change color equal to blue, so it will change the color equal to blue, and change the title of the graph main is equal to this is a nice pair plot or correlation matrix lah. Right. So you also can change the labels equal to pole names dalam AVG, right? I think that's all. And you also can add the PCH if you want to change it to 4. 4 means X kan, so dia akan tukar, right? Then for a nice correlation matrix, we can use a lot of a lot of library, right? Library, for example, library GGLE, can do a lot of interesting correlation matrix. For example, let's say I just showing to you, so later you can review by yourself the GGLE, right? For GGLE, kalau tengok kat sini, just pakai GG pairs AVG, from 1 to 5, right? So it will generate a nice plot with the correlation value lah. Yep, this is the correlation plot. Okay, so it's basically the same diagram, right? Instead of giving both side, upper triangle and lower triangle, the same scatter diagram, for GGLE they give a lower triangle is your scatter diagram, for upper triangle is your correlation value lah, right? So your task here today, your task is basically a simple task I want to use to give to you. Reconstruct box scatter diagram boxplot and histogram, right? Find suitable variable in AVG dataset and sub YTS dataset. So you need to find a suitable variable, right? For in AVG dataset. AVG means the dataset inside the TB dataset, and sub YTS dataset. So you construct a scatter diagram, box plot, bar plot, and histogram. So try to construct as many as you can and try to interpret each of the graph that you have. Alright. So I think that's all. Thank you very much. Assalamualaikum.